Welcome, Hornets, and thank you for joining me today. Today we're going to be taking a look at evaluating some complex integrals. You'll notice in front of you I have a worksheet that has several integrations on it that we'll be working with. I recommend that you go through all of them, not just the odds or the evens, but I've tried to give you a smattering of all of the different topics that we've been covering over the last several days. These will help you prepare for the AP test and get you an idea of what the expectation should be, whether it's with the fundamental theorem of calculus 1 or whether it is just your basic integrations where you're trying to figure out which topic or which method should you use. So I'm going to be starting with the first problem, and in the first problem that you see, you'll notice that we're working with the integration from 0 to 2 of 2 minus t, the quantity, times the square root of t dt. Now, this represents the first basic idea of what we want to do, and we always want to get multiple terms, whether that's multiple terms in the denominator, so that we can separate the denominator based upon how many terms are in the numerator, or whether they're just in the numerator, where we can separate it into different parts. So let's take a look at what we've got. 0 to 2, 2 minus t, times the square root of t dt. I'm going to begin by distributing the square root of t. This will allow me to figure out what I need to work with and see the basic structure that I need. I would now use a u sub if I needed it, but here no u sub is required. We do need to change our power into a 1/2 power so that we can work with this easily. Notice this is going to become t to the 3/2 power, and still 0 to 2, and dt. We now integrate each piece. This is going to give me 2 times 2/3 t to the 3/2 power from 0 to 2, and this is going to be minus 2/5 t to the 5/2 power from 0 to 2. We're now in the middle of the fundamental theorem of calculus that we have to work with. And so I'm going to plug in my 2, and you'll notice that I end up with 2 cubed, so 3/2 power. That's just going to give me 4 times 2 root 2 divided by 3 minus 4/3 times 0. There's the first part. We then do the second part. The second part is now going to give me 5/2. So I'm looking at 2 times 4 root 2, and it's over 5. And then we're subtracting 0 again. Now this is going to give me 8 root 2/3 minus, and I'm looking at 8 root 2/5. We get our common denominator, that's going to be 15ths. And you'll notice that I will have 40 root 2, and I'm subtracting 24 root 2, and my answer turns out to be, oh, you can't see that, but we're just doing the arithmetic, and I get 16 root 2 over 15. And there's my answer to number 1. So you notice that's our basic idea. Let's take a look at number 2 now. Number 2 is the integration from 1 to 9 of 1 over the square root of x, 1 plus root x, the quantity squared dx. This is a u substitution. I know it's a u substitution because the derivative of x, the square root of x, is 1 over the square root of x times 2. So I'm going to go ahead and I'm going to use the u sub 1 plus root 2. This gives me du equals 1/2 to, that should be an x, 1/2 x to the negative 1/2 power. And don't forget my dx. So if I work with this, that's going to mean that I have du equal to 1 over 2 square root x dx. And there is no 2, so I'm going to have to move it over to the other side to have 2 du is 1 over root x dx. I can now begin my substitution, and I'm looking at 1 over u squared du with a 2 in front. This is now going to give me negative, let's see, 3 for, pardon, negative 1/3 as I integrate should be negative 1. What I'm doing is I'm currently doing it in my head, and I probably should just write it out as a negative 2 du. That's where I get the negative 1, divide by the negative, times the 2, and we're using 1 over u from 1 to 9. And I need to back substitute when I'm doing this, so we do have to be careful. So I'm looking at negative 2 over 1 plus root x from 1 to 9. Now when I put in all of my information, you'll notice I'm going to get the square root of 3. That's going to give me negative 1/2. And then I have a minus with a double negative. Because of this 1 going in, I have a minus 1, double negative, and I should end up with 1/2 as my answer. Let's take a look at the next problem. In our next problem, number 3, we're looking at our basic trig. So we have the integration from pi over 6 to pi over 4, or 4 secant theta tangent theta d theta. So here we go. I'm going to put this together. I'm going to bring out that 4. I have pi over 6. I have pi over 4. I see secant theta tangent theta d theta. Here we're just using our basic integration. We know secant theta tangent theta d theta integrates into secant theta. So I have 4 secant theta from pi over 6 to pi over 4. When I plug these in, I end up getting 4 times the square root of 2 from pi over 4 minus 4 times 2 over the square root of 3. Now I'm going to have to clean this up as I go, so I'm going to get my common denominator of root 3, and this is going to give me 4 root 6 minus 8 over root 3. And that would give me, if I keep simplifying, I could see this as 4 over root 3 multiplied by root 6 minus 8. And it would be one of these two answers here. Now I could rationalize. That is always a possibility. And if I rationalize, that means I'm multiplying by root 3 over root 3. I suppose I could then get a new answer, which would be 4/3, and distributing the root 3 in, I would get 3 root 2 for the 18 minus root 6, and I believe that would be what I'd have. So 18, 24. Let's change that so that we would have 8 root 3. There we go. Much better. And these are the possible answers that I would have, and I would move on to the next problem. Alrighty. Let's go ahead and keep going. This brings us to number 4. Number 4 is another type of u substitution that we see. So we're looking at the integration from 0 to pi over 6 of 4 to the power of tangent 2x. And then I have times secant squared 2x dx. So, in this problem, we're going to go ahead and be using our u substitution again. Let's just write this down. Now I'm going to use a double substitution, so I'm going to start off getting rid of this 2x. It's something I really don't want, and I'm just going to have 1/2 du equaling the dx. That'll clean things up quite a bit, make my life a lot better. So I now have e to the tangent of u, and then I'm looking at secant squared u du. Now I can do a v substitution. This is how we work with a double substitution. And I'm going to say I have tangent of u which means that my dv is going to be secant squared u du. 1/2 integration 0 to pi over 6, and then I have e to the u du. I now have 1 over 2, the 1/2, e to the u, and we're going to put in our tangent, and then our 2x, and it's from 0 to pi over 6. We're now able to work with this and integrate. I get 1/2. The tangent of pi over 3 when we multiply it by 2 is going to be root 3. So I have e to the power of root 3 minus 1/2 e to the power of 0. And I'm just going to simplify this so that I end up with 1/2 e to the root 3 minus 1/2, or e to the root 3 power minus 1 all over 2. And this would be my answer for number 4. So these are the first 4 problems of this worksheet, and I will continue in the next video. Thank you very much, Hornets. I appreciate you watching this. If you found this to be useful, please remember to click like, and if you have constructive criticism for me, please make sure you let me know so that I can improve on my teaching. Thank you very much. Be safe, take care, and have a great day. Cheers.